Exercise 4.3, question number 16. Integrate x square plus 1 divided by x plus 1 whole square into e raised to power x dx. Before using the integration by parts, we must simplify this question. Just make complete square in the numerator, because we see this is an improper fraction. This, after opening this formula, we will get x square term, and also we have x square term. We can make both the terms similar by making here x plus 1 whole square. We can make x plus 1 whole square here by using the formula. We know that x plus 1 whole square equals x square plus 2x plus 1. You see here we have x square and 1, but we don't have 2x. So just add 2x and subtract 2x as well. Since this is x plus 1 whole square, so I am considering this plus 2x. And just combining these first three terms, I will get x plus 1 whole square, and the remaining minus 2x will remain as it is here. Now, this denominator can be split into two parts with these two functions. It will be x plus 1 whole square over x plus 1 whole square minus 2x over this denominator, like this. Now it will be cancelled. We get 1 minus 2x over x plus 1 whole square and e raised to power x as it is. Now multiply e raised to power x with the first function and with this second function, and separate the integration into two parts. We will get integration e raised to power x dx minus 2 is a constant, I have taken it outside, integration of x e raised to power x over x plus 1 whole square. Integration of e raised to power x is e raised to power x, and now we see we can make this x plus 1 here again by just adding 1 and subtracting 1. Now e raised to power x, we made it into two parts. Just split it into two parts like x plus 1 and minus 1. Multiply e raised to power x with this one and multiply e raised to power x with this one, and separate this integration like x plus 1 e raised to power x divided by this denominator. Then minus 2 multiplied by minus 1 will be plus 2. E raised to power x into 1 will be e raised to power x over that denominator. Now x plus 1 can be cancelled with one of this x plus 1. When the remaining x plus 1 is moved in the numerator, its power will become negative. Here, if this denominator is moved upward, its power will become negative. I will not disturb this integral, because I know that if I take the derivative of this function, power will convert into minus 2. And we can get back the same integral, and then we can easily cancel the integrals. So just solve this integral, don't solve this next one. Since we know that the integration of these polynomials are derivative of the polynomials. If we take the differentiation of the polynomials show the reduction. So I just took it as first function and this one as second function. First function, use the integration by parts. First function as it is into integration of second function minus integral. Derivative of first function will be power down, power minus 1. And without power, derivative will be 1 plus 0. That will not just have a difference here. And the integration of second function will come as it is. And the last integral is written as it is. Now open this whole bracket and simplify it. We will get minus 2. This is negative power. If we make it down, it will be positive. It will convert it into the positive power. Minus minus plus, and plus minus will be minus 2. E raised to power x and x plus 1 negative 2. Now you see both the integrations are same with opposite sign, so it can be cancelled, and we get e raised to power x minus 2 e raised to power x over x plus 1. Now we can take e raised to power x common. We will get 1 minus 2 over x plus 1. If we just take the LCM and simplify it, we will get x plus 1 minus 2 over x plus 1. That will become x minus 1 over x plus 1 plus the constant of integration should be added at the end of the solution. Question number 17. Integrate cos of ln x dx. Now here you see we have only one function, this one. Now I just wrote it like 1 into cos ln of x so that we can have use the integration by parts formula here. We know that this is difficult to have the integration of cos ln of x because ln of x has no integration. So I have taken this function as the first function and this one as the second function. Now using the integration by parts formula, first function will come as it is into integration of second function minus integral derivative of cos ln x will be minus sin ln of x and the derivative of angle, that is ln x here, is 1 over x, and integration of second is x dx. Now minus minus will become plus integration sin of ln x into 1 dx. Just now again we will do the same thing. You see, in the start we were having cos ln x, now we have sin ln of x. Sin ln of x, you see here trigonometric function, you have taken it first function and here you have taken it also first function. Don't just switch the number of the functions, take it same as it is because we left it equals to capital alphabet and then we will get back that alphabet here. Now again integration of parts, first function as it is into integration of second function minus integral derivative of the first function will give you this thing that I have earlier told you how to take the derivative into integration of second function. Just open this whole bracket, simplify it, we will get this thing. You see, you again get this same integral, just replace it with capital I. Move this minus I to the left side, it will become I plus I, that is 2I. This 2 will be just, this is multiplying here, it will divide on your right side. We'll get 1 over 2x cos ln of x plus sin ln of x plus constant of integration. Question number 18. Integrate under root x e raised to power minus under root x dx. I have just used the substitution here. Let under root x equals to t. Now differentiate both the sides. We will get 1 over under root 2x dx equals to dt. Just move this 2 under root x on the other side. We will get dx equals to 2 under root x dt. And under root x is t, so dx equals to 2t dt. Just replace the values in this question. Under root x, replace it with t. E raised to power minus under root x will become e raised to power minus t, and dx will be 2t dt. Now this 2 is a constant, move it outside, we'll get t into t will be t square e raised to power minus t. Using the integration by part formula, if we take the derivative of this function, because both of them have the integration formula, so don't use the rule 1, use rule 2 in which we have the reduction by taking the derivative. If we take the derivative, this is reduced. Consider t square as first function and e raised to power minus t as second function. Using the integration by parts formula, first function into integration of second function minus integral derivative of first function into integration of second function. Simplify all the terms, multiply this 2 inside, and after simplification you get minus 2t square e raised to power minus t plus 2 integral t into e raised to power minus t dt. Again, I have taken t as first function and e raised to power minus t as second. Using the integration by part formula, and you know that very well, first function as it is into integration of second function minus integral derivative of first function into integration of second function dt. Open this whole bracket, we will get this thing, and at the end we can easily simplify this integration of e raised to power minus t, that is e raised to power minus t over minus 1. Now I can take minus 2 common out of this whole thing. We'll get t square e raised to power minus t plus t e raised to power minus t plus e raised to power minus t and plus constant of integration. Replace t with x. We know that what we let under root x equals to t. So in place of t, just used under root x, and in place of t square, we will replace it with x, because by taking square on both sides, we'll get x equals to t square. So just replace the values, substitute back the values, and take the e raised to power minus under root x common, we will get this answer. Question number 19. Integration of x cube e raised to power 2x dx. e raised to power 2x is considered as second function and x cube is considered first, because on differentiation this x cube can be easily reduced. Using the integration by parts formula, first function as it is into integration of second function minus integral derivative of first function into integration of second function. Take 3 by 2 as outside because it is a constant. Now x square will be again considered as first function and e raised to power 2x as the second function. Use the integration by parts formula again. We'll get first function into integration of second function minus integral derivative of first function into integration of second function. This will become minus 3 by 2 into 2 4 x square e raised to power 2x minus minus plus. This 2 will be cancelled. We'll get 3 by 2 integration x e raised to power 2x. Again we will let x as the first function and e raised to power 2x as second function. Just apply integration by parts formula like this and open this whole bracket. We will get this equation. Integration of e raised to power 2x will give us e raised to power 2x over 2. Now this will become minus 3 over 8 e raised to power 2x. I have taken e raised to power 2x as common from all these terms, and the highest denominator is 8, so I have taken 1 over 8 as common. Since it has only 2, so just you have to write 4 here, because if we multiply 1 over 8 inside, we'll get back 1 over 2 here. Then we get e raised to power 2x over 8, 4x cube minus 6x square plus 6x minus 3 plus constant of integration. Question number 20. Integrate x raised to power 5 e raised to power x cube dx. Now we have here some complicated function. We can make its derivative with itself. We know that x cube, derivative of x cube is 3x square. We can just split x5 as x cube into x square like this. Now you see x cube has the derivative with itself. So just consider it as first function and consider it second function. You know that integration of second function will come. And second function integration now can be easily done due to this x square in the coefficient. X cube is taken as the first function as it is, into integration of second function. Integration of this second function, x square e raised to power x cube. We know that e raised to power x cube, if we have the derivative of this power here, then we can directly write it as e raised to power x cube. But we need to make the derivative here. X cube has a derivative 3x square, but we have only x square here. So just divide it with 3 and multiply it with 3 like this. Now its integration will be easily as e raised to power x cube because its derivative is in the coefficient. So the integration of second function answer is this, minus integral derivative of first function into integration of second function is the same answer. This 3 and 3 is cancelled. We'll get integration x square e raised to power x cube. Now this is again the same integration. So just multiply it with 3 and also divide it with 3. Integration of 3x square e raised to power x cube dx is minus 1 over 3 e raised to power x cube plus c. Now I can take e raised to power x cube and 1 over 3 common, and I will get e raised to power x cube over 3 into x cube minus 1 plus c as the answer.